Hi, today I'm going to talk about algebra. Okay, algebra, of course, still involve numbers. Uh, Using equations, inequalities, to solve some problems. Okay. So first of all, it is about inequalities. Okay, we know that if negative 2a plus 1 is less than 13, question is, what is the sum of the distinct possible okay, distinct possible integers of a. Okay. So this is what we're trying to do is we find the sum of these integers satisfy this inequality. Okay. So basically, just trying to solve this type of inequality. We even have more complicated inequalities. This is not that complicated. We just have absolute value and less than 13, right? So how do you solve an inequality involving absolute value? So you have to get rid of the absolute value symbol before you simplify. Okay, and so the geometric meaning of this inequality is here's 0. So this is a, this is negative a. So any x, okay, in this interval satisfies this inequality. So in other words, this is equivalent to x less than a greater than negative a. Okay. So about the inequality, can be changed to this one. Then step by step, you solve and you move 1 to both sides at the same time. So it's 13 minus 1 is 12. Negative 13 minus 1 is negative 14. Okay. Now, here's the trick. You have to divide by both sides by negative 2. When you divide by negative 2, you have to change the direction of the inequality. Okay. So finally, you will get 7 greater than a greater than negative 6. Now, how many integers satisfy this inequality? Well, a is going to be negative 5, negative 4, negative 3, right? And 0, negative 2, negative 1, 1, 2, 3, 4, 5, 6. So when you add them together, right, when you add them together, all of them will be canceled out. Right, all of them will be canceled out. So the sum is just going to be at 6. Okay, the sum is just going to be 6. Right, I wanted to solve this following inequality. Okay, so I hope you remember how to do it. So 3 minus 2 at absolute value negative 3x minus plus 2, okay? Should be greater than should be greater than 5. Yeah, no, should be greater than 2 here. Okay. Okay, please work out this problem. Anyone have answers? Well, huh. Well, step one, you have to simplify this inequality before you get rid of absolute symbol. So you move 3 to the right hand side, so 2 minus 3 is -1. Right? Then you have to clean this side. Divide both sides by -2. When you divide by -2, you change this direction of inequality. -1 divided by -2 is just equal to 1/2, right? Okay. Then you can remove the inequality as a Bessel symbol. Then you move 2 to the both sides, -3x less than greater than -1 minus -2. So let's simplify it. And this side is -3/2, and this side is -5/2. Then you divide both sides by -3. But don't forget to change the inequality. Okay, so finally, you will get 5/6 greater than x greater than 1.5. So you take a look, change the direction. I think this is fine. 1/2 is less than 5/6. Okay, Grant, great. Okay, now we're going to try to solve equations. X and the Y are positive integers satisfying this inequality as this 4y plus 2x equals x times y. Okay. The question is, what is the largest possible value of this one side, x times y, or 4y plus 2x, doesn't matter because they're always equal, right? Okay. Do you have any idea? Well, what can, here we only have one equation, two variables, right? Of course, you cannot uniquely determine x and y, but there's a hidden condition, positive integers. So that means maybe you only have a finite many solutions, right? So this solution can find the largest product. So let's try to solve this problem. Okay. You can solve for x first, for y, right? Equals xy minus 2x. I have to get the x out, so y minus 2x. So x is going to be 4y, y minus 2. That's one equation, right? And you can also try and solve for y. So 4y, 2x equals xy minus 4y. So you get x minus 4y. And then y is going to be 2x, x over 4. Now, since y is a positive integer, right? So from here, I can tell y should be greater than 2. Right? And here, x should be greater than 4. Right? So clearly, y is greater than 2 and x is greater than 4. Okay. So I'm going to focus on the second one. Okay. And so what are the possible values for y? 2x, right? So just take a look at the y. Y equals 2x, x minus 4. I know it's greater than 2, okay? I know it's greater than 2, right? Yeah, what is the largest possible value for y? Okay. This actually is decreasing when x is getting large, and that'll be decreased. So what I'm going to do is, for example, I can express it 2x minus 4 plus 4. That's a tricky, okay? So I separate it 2 plus 2 times 8, x minus 4. So clearly this term is getting smaller and smaller, then eventually y approaches 2. But the largest possible value for y is going to be, right? So when x equals 5, right? Because the x is greater than 4, so x is than 5, y equals, right? Y equals 2 plus 8 over 1, which is 10. So I think the y value is between 2 and less than equal to 10. So can y be any of them? Right? So then you immediately solve the problem. You know what? Because largest possible value for y is 10. The largest, now here's a, when x starts from 5, yeah. Well, when x increases, y decreases. Okay, so that's the first one. Okay. I'm just trying to find other solutions. Okay, trying to find other solutions. Now, in order to get integer y, 8 should be divisible by x minus 4, right? So clearly, x minus 4 should be even number, because otherwise, yeah. And there are not many choices. right? 8 should be divided by x minus 4, right? So 8 should be divided by x minus 4, then it should be 8 divided by max equals 1, right? Besides, if it's greater than 1, you know, right? Okay, so let me, well, if, how do you, in order to get the integer, right? X minus 4 should be 1, right? It's 2, 4, and 8. Do you agree, right? Those are the values you can choose. Right? So in other words, x should be equal to 5, 6, 8, 12. Right? In each case, you get the y value, y is 10, right? When x equals 2, x minus 4 equals 2, 8 divided by 2, 8 divided by 2 is 4, 4 plus 2 is 6. Right? Then the next number is when x minus 4 is 4, it's 2, 2 plus 2 is 4. Right? X minus 4 is 8, right? It's 23. Yeah. So now you look at the product, right? Here's a 50, 36, right? And then 36. So this is going to be the answer. But anyway, you have 4 solutions, clear, right? You have 4 solutions to that equation. Okay. So usually when you have an equation in 2 variables, if the 2 variables are integers, and more likely you're going to have only finite many solutions, or use 2 or 3 solutions, then you choose the largest or smallest value you want. Right. So our next problem is find an ordered pair x and y of even integers with x less than y, and 1 over x plus 1 over y equals 1/3. Yeah. So this is actually is a question again, right? One single equation, right? One single equation, and the x, y are not only just integers, are even integers. Right, so you're going to have only finite many solutions, maybe only one solution. So let's, yeah. So this is a type of problem similar to the above one. Right, there are a couple ways to do it. One is by guess and try. Right, another way to do is using the method I showed to you. 1 over y equals 1/3 minus 1 over x. Then you get 3x, x minus 3, right? And then turn upside down, express y in. Okay? And then you get exactly similar equation like we did again. So the trick here is you change it to this form, it looks much better. So you get 3 plus 3 times 3 is 9, 9 minus 3. Okay? And then from here, you can tell that x minus 3, 9 should be divided by x minus 3, it's 1, right? And the 3, right? And the 9, right? Those are the possible 3 solutions, right? So in this case, x is going to be 4, right? X is going to be 4 and 6, 5, so, 4, yeah, 1 plus 6 and 12. So the corresponding y value would be, right, 9 over 1, that's 12, right? 3 plus 9. And then 9 divided by 3, it will be 3 plus 3 is 6, right? 9 divided by 9 is 1 plus 3 is 1. Okay. So you basically have a two, without any, just assume they're integers. You have this essentially two solutions. Right? Another one is 1 over 6 plus 1 over 6 is. But if we look at our assumption, okay, if we look at our assumption, yeah, that satisfies our assumption that both are even numbers. However, we assume that x is less than y, right? So this will be the same, right? This will be the solution. Okay, the answer is 4 and 12. Okay. That is, I think this should be the good way to solve a problem. Okay, instead of guessing try. Right. We are dealing with those equations and equations. Our next problem. A little bit more complicated now. Positive integers. Okay. N, X, Y. They're all each less than 10. So there are only the restriction there. So if x squared minus y squared equals n, so you're going to have many solutions of that. So I'm going to do is to find the median of all possible values for the sum x plus y plus n y. And this is one of the problems of the math course. So what we're trying to do is find the solutions, right? Those are only finite many solutions. Because x, y, n are all less than 10. Then you add them together. Then you find the median, right? Yeah, there's no trick here, just to try to find possible solutions. And let me double check. Okay, y cube, not the y square. Y cube. So y cube increases much faster than x squared. So you should try y cube, x squared equals n plus y cube. Right. So I think one can quickly get all the solutions. Just let the y to be, because the possible value for y is going to be y equals 1, right? I think 2, right? And y is less than 10. And 3 is okay. And 4 is 6 foot. You see, y cannot be 5 because 5 cube is 100 if y is 5 cube, okay? If y equals 5 cube, right? X squared should be greater than right? 5 cubed, which is 125. So x must be greater than 10. So already exclude. So you already have a fixed possible, right, solution, right? So you can try this one by one, right? Then you then you look at each case. If y equals 1, x squared equals n plus 1. You know, when this can be when this is going to be a perfect square. What kind of value, right? You can choose, right? So perfect square, you can see that perfect square is, you know, from here is 4, right? And 4 and 9, right? And the 16, 25, right? So, however, since n cannot be larger than 10, right? So n cannot be larger than 10. So you exclude this, just stop there. So then you only have two solutions, right? When n equals 3, right? X is going to be 2. When n equals 8, x is going to be 3. See? So that's how do you solve this equations. Okay. Okay. So you get the first set of solution, right? You get x, right? Yeah, x, y, and you get 1, you get 2, 1, and 3, right? And you also get 3, 1, and 8. Then you look at the second case, y equals 2. So x squared equals n plus 8. Now, n plus 8, you know, the largest possible value here is 4 and 9, right? X squared cannot be wait a minute, x squared, yeah, because n, the largest possible value for n is 10. So 16 should be included, right? Just because n is less than 10, okay? N is less than 10. And then this should be excluded, right? Because n plus 8, right? So that's two possible solutions, right? And so this is right, when n equals 1, right? X is going to be 3. When n equals 8, right? When n equals 8, then x is going to be 4. So you get x and y, and you get two sets of solutions, 3 and 2 and 1. Another set of solution is going to be 4, right? It's 2 and 8. Okay, so if y equals 3, y equals 3, that's the way how do we step by step again, right? It's n plus 3 cubed. 3 cubed is 27. Now if it's 27, right? Yeah, 3 cubed is 27. Can we have a solution? Because n is between 1, right? And this has no solution because this is already, hold on. So now it's answered. Okay, well, it's okay. So n equals 23, right? So what are the possible values here? When n equals 1, 20, right? And the next perfect square after 27, right, is going to be 36, right? Then after that, a much larger sense, 49. But 49 is impossible because n plus 27 cannot be 49, right? So there's only one solution here when n equals, when n equals 9, right? When n equals 9, you get 37. So in this case, x is going to be 6. So there's only one solution here, 6 and the 3 and the 9, right? So the last one, I hope I still have a solution. X squared equals, right, n plus 4 cubed. 4 cubed is 64, I think, right? So what is next? What is the next perfect square? 64. It's 81, right? But it's impossible. This is impossible, no solution. Okay? So that's impossible, no solution. So basically you get how many solutions you can get? 1, 2, 3, 4, 5. And you can get all the sums, right? The sum is going to be, the first number is going to be, 6. The second number is 12, right? Yeah. The third number is 6. This is going to be 14. And then you have 18, right? So 12 and 14 are the numbers, right? So you have 3 different, 6, 12, 14, 18. So you got those numbers, right? Yeah, you got those numbers. So the answer will be 12 by 14 divided by 2. Right. So all possible values, although 6, 6 are repeated, but they're not only counted once, okay? So then this is the answer. Right, this is going to be the answer is 13. Right. So all possible values you get is 6, 12, 14, 18. But that thing is a key point in trying to get all the solutions. So there are only finite many solutions. All right. It's pretty challenging, right? But if you're patient enough, find the way step by step, then you should be able to get all the solutions quickly within. This is probably a given 3 minutes to solve. Okay. Our next problem is what is the smallest value of k for which 4x squared plus kx minus 16x plus 36 is a perfect square. Now, what does it mean, perfect square? Perfect square means it's going to be something square, okay? And then this must be a linear term, ax plus b. There are a, b may not necessarily be integers, okay? But this must be a linear term. So think about it, okay? How do you solve this problem? Right, I give you a minute to think about. Okay. Okay, I'll give you a hint. Okay. If it's perfect square, means this is equivalent to saying that it has a unique root. The root means a solution, okay? Because when you set this to be 0, x plus b 0, right? It's only one root. It's not like two distinct roots. Right? If a squared plus bx plus c, the roots are negative root plus minus b squared minus 4ac and 2a, right? So when it has a unique root, that means when, when b squared minus 4ac equals 0, okay? This implies unique roots. Okay, right? Which is negative b over 2a. Okay, so when we go back to the above equation, now this equation, when it has a unique root, okay, it has a unique root if and only if, right, k minus 16, that's b squared, minus 4ac is going to be 0. So k minus 16 square equals 4 times 4, 4 squared, 6 squared, 24 squared, okay? So k minus 16 plus or minus 24. So k equals 16 plus or minus 24. You have two solutions, add them together, a 40, subtraction, negative 8. 16 minus 24. So the k has two possible values. That's it. So you see this problem, there are only two possible values for k. So you can make it a perfect square. The answer is k coordinate, the smallest value. Well, you see, you have to find a point, get in, right? So when it's become perfect square is when it has only unique root. Okay, so if it has a unique root, right? Then so if if b squared minus 4ac equals 0, right? Ax squared plus bx plus c, has a unique root. So x minus actually is plus b over 2a squared, okay, in this particular case. And the root is doing that. Then a is a positive here, okay? Otherwise, it cannot be perfect square. So a is positive, you move a into, then you get b over square. I think so. Okay. that will be a perfect square. Now, so even we can figure out whether what is the answer here? Perfect square. Okay? When k minus 16 equals negative 24. When k equals negative 8. Okay. Our equation here 4x squared. That would be actually 24x 36. Okay. So this will be perfect square. If you take a 2 or 4 out, it's x 6x. Okay. So it is 4x minus 3 squared. You can move inside 2x minus 6 squared. Okay, it's perfect square. Okay, great. So we double check, right? It's perfect square. All right, what is our next problem? Wow, we are dealing with equations, right? So here, if x, y, z are positive integers, and such that x squared plus y squared plus z squared equals 174. Wow. So this is similar style, right? What is the greatest possible value of x plus y plus z? Right? Wow, how can you do that? I'm going to give the hint. Okay. I don't know. What I can think about is this square, which is x squared plus y squared plus z squared, and 2xy, 2yz, and 2zx. Okay. So this is identity that came out to my brain immediately. Maybe I can use it, maybe I cannot. Okay. All right. I think if we use this identity, we want to find the largest possible value. All I have to find is what is the largest possible value of this. And this is a fact. It's 174, right? If you can make x, y, y, z, zx as large as possible, then you solve the problem. And we also have the following inequality. 2xy is less than or equal to x squared plus y squared. Okay? So 2yz is less than y squared plus z squared. And 2zx is less than zx squared plus yx squared. So if you put that, and then you will get x plus y plus z squared is less than or equal to 174. And you have this, that, right? Get them together, you get twice of x squared, and twice of y squared, twice z squared. And then again, this can be replaced by 174. Right. This can be replaced by 174, so that is going to be 519. Okay, 519. So we at least we get an upper bound, right? Square root of 519. Now you are allowed to use calculator. It's 22.78. So my conclusion is x plus y plus z is less than or equal to 22. Now is 22 is the largest possible value? Because when you get a value, you get a solution. You are wondering whether this is the largest possible value. Okay. Okay. What I'm trying to do is I do a guessing try. Okay. I use I remember special values. Okay. So what I'm trying to do is because x squared plus y squared plus z squared equals 174. So you can try x equals 1, x equals 2, 3, 4, and 5. And then you try to find the special solutions, special integers satisfy the Pythagorean theory, right, in the equation. Okay, so and you can quickly figure out only when 174 minus 5 squared. Okay, 5 squared is 25, right? It's 9, 100. Yeah, 174 minus 25. That is not 6. It's 140. Yeah, 140. Okay. Okay. Then I see that, okay, then I can get 7 squared, 10 squared, it's going to be 149. So anyway, so we get a solution. Okay, you don't need to find all of them. Just find the 5 squared plus 7 squared plus 10 squared equals 149. Okay, so the sum is already equal to 22. So that is good enough because we know if I do not do the analysis at the very beginning, okay, if I do not do the analysis at the very beginning, I cannot tell this will be the solution I want, the answer I want, because maybe I have another set of special solutions so that the sum is going to be greater than 22, right? Because I already said that at the very beginning. It is great. It is largest possibility is 22. So we find it. Okay, I think this is difficult. This problem, yeah, so you have to by guessing try. It takes a little bit more time to solve. Okay, let's do a little bit easy one. I hope you can finish it. Okay, if x, y, positive integers less than 20, and for which x plus y plus x times y equals 76. Find the values of x plus y. Okay. So the equation yeah, there are a couple ways to solve this problem. Okay. Remember the method I showed to you. All right, let's do this problem. Some we already figured out. 16. Like this. Go ahead. And there are a couple ways to do. One is when people trying to use the old method that we learned, right? So it's going to be 1 plus x, y equals 76 minus x. Then y equals 76 minus x, so 1 plus x. So this is a problem here, whether you can get the integer, because x, y must be integer, right? Right? So when this can be integer, right? So we can try this. Let's see, 76, and I'm going to change it to this, right? Yeah. So make that one 77, 1 plus x minus 1. Okay, so this become integer if only if 77 over 1 plus x. This is going to be integer, right? Right? So we want to see when this can be integer. But 77 is going to be 7 times 11. Okay, and the 1. Right? So this is this. So x 1 plus x cannot be 1, right? Cannot be 1. So the next possible value is 7, right? Or 11. Okay, and I think it cannot be 77. Why? Because our x is less than 20. Okay, so you get two solutions, right? So when x equals 6, 1 plus x equals 7. So y is going to be, right, 77 divided by 7 minus 1, so it's 10. Okay, that's the first set solution. Second set solution when it's 11. Okay, y is going to be 77 divided by when x is when x plus 1 is 11, when x is 10. Right, so that'd be 11 minus 6. So it's 7 minus 1, which is 6. And you essentially get the same sets of solutions here. Right, so that's it. So you get x equals, because x and y is another in the equal position. So there's only one solution here, surprise. Okay, so it's only one set of, essentially it's only one set of solution. Okay, so you have a 6 plus 10 plus 6 times 10, which is 76. Okay, so the answer is, the answer is it's going to be x plus y, which is 6. Good. Another way to solve the problem is, it's a little bit tricky here. Another way to solve the problem is x plus y plus x times y. This actually, well, it's not going to be a product to terms. Okay, but I remember 1 plus x, 1 plus y is going to be 1 plus x plus y plus x times y. Y, it's here. So that is given, which is going to be 76 or 77. So you have the 1 plus y times 1 plus x is going to be 77. So the possible 77, right? And this is greater than 1, this is greater than 1. So I guess 1 plus x equals 7, and 1 plus y equals 10, or vice versa. Okay. So that implies x equals 6, y equals, 11, y equals 10. All right, so this is another way to solve the problem. But this is a little bit difficult than the previous one. The previous one, I said that this is a pretty standard trick here, right? And you always express y in terms of x. And another trick here is that there's x involved on the top, and you should separate. Then you can easily see when it's going to be the integer, when this is going to be the integer. Okay, and then you find all the possible solutions. Okay, I like the first method than the second one. Okay, the second one is pretty tricky here. Just a special case where you realize that you can get 1 plus x times 1 plus y. So then you quickly solve the problem. Okay, so we can practice on another problems. Find here's questions. Okay, find all positive integers satisfying x and y. Okay, satisfying 2x plus 3y equals 100. Okay. Now I can even put another large number 50. It's fine. Okay, find all the solutions. Clearly, there's one solution that x equals x equals 10, y equals 10. Right? X equals 10, y 10. So let's quickly solve the problem. So what they do is you solve for y. So 50 minus 2x divided by 3. Okay? Divided by 3. And then, right? Then you will see, right? You take 2 out. So we are running out of time. Okay, they are not. You just want to see when it's divisible by. You take 2 out, right? It's 25 minus x divided by 3. So all you have to do is make sure 25 minus x is divisible by 3. Okay. Okay. So anyway, this is a number. It's not bigger than 25, right? So it's going to be divided by 3. It's 3, right? 6, 9, 12, right? Divided by 3, 15, 18, 21. Right, 21 and plus 24. Okay, so those are the possible, because why not beyond that? Because then the x is x is positive integer, so 25 is minus x is less than 25, right? Okay, so then you get x, then you get the corresponding y value, so you get all the solutions. Okay, so that's divisible by 3. So the corresponding y value is going to be, if this is a 3, 3 divided by 3 is 2, and this is a 2 times 2 is 4, right? And 3 times 4 is 6, and this is a 4, 8, right? And this is 5 to 10, and that's, okay, 6, 12, 14, and 16. Okay, so that's corresponding y value. So that's why you get all the possible solutions. And then you can solve for x here. X is going to be, right? 25 minus 22, minus 3 is 22. And so on. Okay, so that's it.